Alright, so today we're going to go over section 4.3, which is right triangle trig. And so if we look at this specific right triangle, and we look at our angle theta, then we can figure out our 6 trig function based on that. So we know that the sine of that angle is going to be our opposite side over our hypotenuse. And your hypotenuse is always your diagonal. Cosine is your adjacent side, so your connected side over your hypotenuse. Tangent is your opposite over your adjacent, and so these are usually like abbreviated so TOA. That only gives you your first 3, and then your inverse functions are going to be them for the over. So cosecant is our inverse of sine, so cosecant is hypotenuse over your opposite side. Secant is the inverse of cosine, so hypotenuse over adjacent. And cotangent is your inverse of tangent, so adjacent over your opposite. So if you can figure out these 3, then you'll know that these ones are just the opposites. You really only have to know these 3. And then our original geometry, because we're going to need to use that at some point during this lesson quite a few times to find some of your sides. So that Pythagorean theorem for right triangles is always a squared plus b squared equals c squared, and c is always your hypotenuse. So it's leg 1 plus leg 2 equals hypotenuse, all squared. Okay, and that just comes from geometry from a few years ago. So if we look at example 1, we're given this triangle where theta is on the left. It's a right triangle with legs of 3 and 4, and we don't know our hypotenuse, and we need to find our 6 trig functions. So we know that sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And once I know those, I can figure out the rest of my trig functions. But in order to do that, I need to figure out what my hypotenuse is. So that's where your Pythagorean theorem comes in. So 3 squared plus 4 squared is going to equal my hypotenuse squared. I know that 3 squared is 9, 4 squared is 16, and I know that 9 plus 16 is 25, so 25 equals my h squared, so h equals 5. I square root both sides, so h equals 5. H would actually equal positive or negative 5, but you can't have a negative side length, so h is just 5. So once I know that, then I can figure out my 6 trig functions. So I can also figure out the cosecant is the inverse of sine, so hypotenuse over opposite. Secant is the inverse of cosine, so hypotenuse over adjacent. And cotangent is the inverse of tangent, so adjacent over opposite. So if I start plugging stuff in, then I know that my opposite side of my angle, the side furthest away, is 4. And my hypotenuse, we just figured, is 5. So sine is going to be 4 over 5. For cosine, I know that my adjacent side, my side connected to my angle, is 3. And my hypotenuse is 5. So 3 over 5 is going to be cosine. Tangent is opposite over adjacent, and we just said that my opposite side is 4. My adjacent side is 3, so tangent's going to be 4/3. And if I just start flipping, cosecant is the inverse of sine, so instead of being 4 over 5, it's going to be 5 over 4. Secant is the inverse of cosine, so instead of being 3 over 5, it's 5 over 3. And cotangent is the inverse of tangent, so instead of being 4 over 3, it's 3 over 4. Okay, so any questions on the first one? Oh, pretty straightforward. For then 1b, we're given that triangle with a hypotenuse of 4, a leg of 2, and another leg that we don't know. And we're asked to find our 6 trig functions. So I'm going to start with my Pythagorean theorem, which tells me a squared plus 2 squared equals 4 squared. Okay, so when I plug everything in, 2 squared is 4. 4 squared is 16, so a squared plus 4 is 16. So if I subtract 4, a squared equals 12. And then take the square root. 12 is not a perfect square, so I'm going to leave it as the square root of 12. So I know that a is the square root of 12. Okay. It's easier for me to do it that way than to try to round it to 3 decimal places. So the first thing that I'm going to find is sine. And sine is always opposite over hypotenuse. So in this case, my opposite side is 2. My hypotenuse is 4. And 2 over 4 reduces to 1. So then my sine is going to be 1/2. For cosine, cosine is adjacent over hypotenuse. My adjacent side we just found was the square root of 12. And my hypotenuse is 4, so cosine is square root of 12 over 4. My tangent is opposite over adjacent. My opposite side is 2. My adjacent side is square root of 12. So I put 2 for square root of 12 for tangent. And then for the rest of them, cosecant, secant, and tangent. Cosecant is the inverse of sine, so instead of being 1 over 2, it's 2 over 1, which is just 2. Oh, sorry. Secant is the inverse of cosecant, so instead of being square root of 12 over 4, it's 4 over the square root of 12. And cotangent is the inverse of tangent, so it would become square root of 12 over 2. So does all of that make sense? Okay. Makes sense. Alright, so then the other ones that we need to know are fundamental trig identities. And there's 3 different kinds of fundamental trig identities. There's reciprocal identities, quotient identities, and Pythagorean identities. So we're going to start with our reciprocals. Your next identities are called your quotient identities, and your third set of identities are called your Pythagorean identities. So your quotient identities are tangent equals sine over cosine, and cotangent equals cosine over sine because they're inverses. And then your Pythagorean identities come from your Pythagorean theorem. That's why they're named Pythagorean identities. And the first one is that sine squared plus cosine squared will always equal 1. 1 plus tangent squared equals secant squared. And 1 plus cotangent squared equals cosecant squared. Alright, so let's actually use some of those there. So an example 4a, given that sine of theta equals 0.6, and we're asked to find cosine of theta and tangent of theta. So I need to start picking out identities that have, first I need to pick out an identity that has cosine in it so that I can use that to find cosine. So if I look at my trig identities that have sine to begin with, the only one that helps me find cosine is the sine squared plus cosine squared equals 0. And so you have to sort of match your information with what you've got and what you need. And so if I start with that trig identity, that Pythagorean identity, sine squared plus cosine squared equals 1. I know that sine is 0.6. So I'm going to have 0.6 squared plus cosine squared equals 1. And so what's 0.6 squared? 0.36. So 0.36 plus cosine squared equals 1. Yep. Then we subtract the 0.36. So I get cosine squared of theta equals 0.64. So my square root both sides to figure out that cosine of theta equals what? 0.8. Okay, so I found cosine, so that was the first thing that it asked me to find. The second thing that it asked me to find was tangent. And I know that tangent of theta is sine over cosine. Okay, so then if I want to find tangent of theta, I know that my sine is 0.6, and I know that my cosine is 0.8. And what is 0.6 divided by 0.8? So I know that tangent is 0.75. So my cosine ends up being 0.8. My tangent ends up being 0.75. Okay, let's do a few more of those because it's sometimes hard to identify which trig identities you want to use. So if I'm given cosine of theta equals 0.96, and I'm asked to find sine and tangent, we're going to use the same trig identities that we used before. You'll use the sine squared plus cosine squared one a lot. So sine squared plus cosine squared equals 1. Well, I don't know what my sine is, so that's going to say sine squared. My cosine squared was 0.96, so squared equals 1. What's 0.96 squared? .96. 0.9216. Okay, so I get sine squared plus 0.9216 equals 1. Then I have to subtract my 0.9216 from both sides. So what's 1 minus 0.9216? Seven. Seems to be another 0 in there. 0.94. 84. Okay. So 0.0784, and then the last step is we have to square root to figure out what sine itself is equal to. 0.28. So sine is 0.28. Second thing I had to find was my tangent. And I know that tangent is equal to sine over cosine. And I now know my sine and I now know my cosine. So I know tangent is equal to the 0.28 divided by 0.96. And so what does that become? So like 0.292 if I round it. Okay, so 0.292. We'll use this trig identity a lot. It's probably like the most common trig identity used. Let's do one more. So tangent of theta is equal to 3. We need to find cotangent and we need to find secant. When I look at my trig identities that include tangent and cotangent, I know that cotangent is equal to 1 over tangent because they're inverses. So then I know that cotangent of theta is equal to 1 over my tangent, which in this case was 3. So cotangent is simply 1/3. That one wasn't so bad. The second part of what I need to find is my secant. And so if I'm looking for my trig identities that include both tangent and secant, then I know that the one that includes both of them is 1 plus tangent squared equals secant squared. That's the one. Okay. So then, using that information to know then that 1 plus 3 squared, because tangent is 3, is equal to secant squared. 3 squared is 9, so 1 plus 9 is equal to secant squared. And 1 plus 9 is 10, so 10 is equal to secant squared. And then if I square root both sides, what's the square root of 10 to 3 decimal places? .162. So I know that then secant squared is equal to approximately 3.162. Guys feeling good? You want to do one more? Good? Okay. So you guys are going to work on those trig identities and those trig functions. 306, 5 through 35, only do the odds.